Everything you can touch, pencil, paper, you and me, is built from unimaginably tiny atoms. Atoms are mostly empty space, a dense central nucleus surrounded by a fast, fuzzy cloud of electrons. Early experiments showed it. Most particles sailed through gold, but a few ricocheted, proof of a compact nucleus. The nucleus holds protons and neutrons. Electrons occupy regions called orbitals, clouds, not little planets. An atom is about an angstrom wide. The nucleus is 100,000 times smaller. The number of protons defines the element. 1 is hydrogen, 6 is carbon, 8 is oxygen, and so on. Isotopes share protons but differ in neutrons. Carbon-14's extra neutrons make it useful for dating ancient remains. Atoms that lose or gain electrons become ions, the charged building blocks of salts, sparks, and nerve signals. Orbitals have shapes: spheres, dumbbells, clovers. Electrons fill them in steps, guiding the periodic table's patterns. When electrons jump between levels, they absorb or emit light at precise colors, an atomic barcode. Chemistry springs from electrons. Ionic bonds trade them, covalent bonds share them, and metals let them roam. Even weak attractions matter. Hydrogen bonds make water weird, in a good way, giving ice its float and DNA its shape. Inside the nucleus, protons and neutrons are made of quarks held by gluons, the carriers of the strong force. 4 forces run the show. Strong, glues the nucleus; electromagnetism, binds electrons; weak, changes particles; gravity, guides the big picture. Binding energy peaks near iron. Fusion of light elements and fission of heavy ones both release energy by moving toward that peak. In stars, hydrogen nuclei fuse into helium, lighting the universe and forging the first steps toward heavier elements. Heavier atoms emerge in stellar furnaces and supernovae, which scatter ingredients for planets and life. Unstable nuclei may change by radioactivity, alpha particles, beta electrons or positrons, and penetrating gamma rays. You can even see particle tracks in a simple cloud chamber, atoms announcing themselves in streaks of mist. Modern tools can map atoms on surfaces. Scanning tunneling microscopes feel their way atom by atom. The Bohr model was a stepping stone. Quantum mechanics replaced orbits with probabilities that match experiments. At small scales, certainty blurs. The more precisely we pin position, the fuzzier momentum becomes. Electrons act like particles and waves. Diffraction shows their wave-like side, a cornerstone of quantum behavior. Everyday clue: static cling. Electrons shifting between surfaces create forces you can feel on your sleeve. Heat atoms and electrons leap. When they fall back, they glow specific colors, how we identify elements in stars. Helium was spotted in the sun before Earth. Its spectral lines revealed an element we hadn't bottled yet. Table groups behave alike because they share outer electrons. Why sodium and potassium are reactive cousins. Life is atomic architecture. Carbon frameworks, oxygen in combustion and breath, iron hauling oxygen in your blood. Electronics rely on controlled imperfections. Dopants tweak how electrons move in silicon to make chips think. In hospitals, atoms help image the body. Positrons from tracers meet electrons, flashing gamma rays we can map. In reactors, fission splits heavy atoms to release energy. In stars, fusion merges light ones. Different routes, same physics. With radioactivity, safety is 3 words: shielding, distance, time. Practical rules built from atomic behavior. Chemistry tracks electrons in reactions. Physics tracks the nucleus and the forces inside. Together, they tell the whole story. There's antimatter too, like positrons, the electron's mirror. When matter meets antimatter, energy appears as light. With lasers, scientists cool atoms to near absolute zero to study quantum states that behave like one giant wave. Materials get their strength from atomic arrangements, planes of atoms sliding, locking, or stretching under stress. Table salt forms cubes because sodium and chlorine pack neatly, geometry written in charges and sizes. A flame is atoms trading partners fast, old bonds breaking, new ones forming, energy flowing out as heat and light. Each breath shuffles atoms, oxygen into cells, carbon dioxide back out, a quiet atomic economy keeping you alive. Most of you is oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus, star-forged atoms arranged with care. When stars die gently, they exhale atoms that later assemble into rocks, rivers, and living things. Hold a meteorite and you're holding star-made metal, the same atoms that run through your blood. Recap: electrons in clouds, a quark-built nucleus. Forces that bind, light as a fingerprint, bonds that build. From quarks to you, atoms are the alphabet of matter. Learn the letters and the world starts to read itself. The same rules shape mountains, medicines, and microchips. One toolkit, many stories. like, comment, and subscribe for more videos like this.